In 2017, a team of computer scientists ran an unreadable 600-year-old manuscript through an AI language model, and the algorithm gave them an answer: Hebrew. Headlines went out within days, calling one of history's most stubborn mysteries finally solved. There was just one detail most of those headlines left out when the researchers tried to actually turn that result into a real, readable sentence. It didn't work. Not without manually correcting the spelling, not without running it through Google Translate afterward, just to make it sound like coherent English at all. This book has beaten cryptographers, chemists, botanists, and now artificial intelligence, and it's still sitting completely untranslated today. By the end of this video, you'll understand exactly what modern computational research has actually found inside this manuscript, why the big viral solved-it claims keep collapsing under expert scrutiny, and why, after literal decades of genuinely rigorous science thrown at this book, nobody, human or machine, has produced one single confirmed translated sentence. Subscribe before we go in, because this is one of the rare cases where the real, careful science is actually more interesting than the fake headline. Start with how this book even reached us. In 1912, a rare book dealer named Wilfred Voynich was going through old chests of manuscripts at a Jesuit property, outside Rome property being sold off after the Italian government had already confiscated much of the Jesuits' other holdings. Among them, he found a strange volume he later described as an ugly duckling, filled with unreadable looping script and illustrations of plants that matched no known species. A letter tucked inside the pages, written by a Prague scholar named Johannes Marcus Marci in 1666, claims the book once belonged to Holy Roman Emperor Rudolph II, then passed through a court alchemist, a collector named Georg Beresch, and finally to Marci himself, who mailed it to the Jesuit scholar Athanasius Kircher, hoping he could crack it. Kircher never did, and the manuscript disappeared from the historical record for over 2 centuries until Voynich rediscovered it in 1912. After Voynich's death in 1930, and a handful of private owners, the book landed permanently at Yale's Beinecke Rare Book and Manuscript Library in 1969, catalogued as MS-408, where it remains today. In 2009, University of Arizona scientists ran radiocarbon dating on the manuscript's vellum pages and traced the material to somewhere between 1404 and 1438, settling, definitively, that this is a genuine object from the early 15th century, not a later fabrication built to fool collectors. What that dating couldn't settle was anything about what the roughly 240 surviving pages out of an estimated original 272 actually say. The text is written in a flowing, looping script matching no known alphabet on Earth, alongside illustrations of unidentifiable plants, star charts matching no known sky, and human figures nobody has fully explained. Paleography specialists studying individual letter forms believe several different scribes worked from the same invented alphabet. For centuries, codebreakers, chemists, and botanists all took their turn. Every one of them walked away without a single confirmed word. Before AI ever touched the manuscript, a language professor made the first major modern attempt. In February 2014, Stephen Bax at the University of Bedfordshire published a paper claiming to identify around 10 individual words by matching them to illustrated plants and stars sitting next to the text, borrowing a technique similar to what once helped crack Egyptian hieroglyphs: hunting for proper names first and building outward. He proposed readings for words including juniper and coriander, plus a possible reading for the constellation Taurus. Press coverage was immediate and dramatic. Bax himself was considerably more careful than the headlines, repeatedly describing his findings as provisional and partial. Other Voynich researchers, including Gordon Rugg, reviewed the paper directly and said publicly they weren't convinced, pointing out that Bax's method for identifying the underlying language was so open-ended it could theoretically fit almost any language, known or unknown. No wider group of linguists ever confirmed his readings, and the claim quietly faded without becoming an accepted decipherment. That exact pattern, a confident announcement, followed by a quiet retreat once other experts looked closely repeated a few years later, with a considerably more powerful tool behind it. In 2017, University of Alberta computer scientist Grzegorz Kondrak and graduate student Bradley Hauer built on an idea Gordon Rugg had floated back in 2004 that the manuscript's odd word patterns might resemble alphagrams, meaning anagrams with their letters rearranged into alphabetical order, running modern natural language processing tools. They first trained their algorithm on the Universal Declaration of Human Rights, translated into 380 different languages, testing whether the system could correctly identify a scrambled text source language even after its letters had been shuffled alphabetically. It worked, correctly naming the source language roughly 97% of the time. Pointed at the actual Voynich text, the algorithm's answer surprised the researchers themselves. They'd originally suspected Arabic. Instead, it flagged Hebrew as the most likely candidate. Testing the theory that the original Hebrew letters had been alphabetized and stripped of vowels before being encoded in the invented script, they generated headlines within days calling the mystery solved. What happened once other experts actually read the paper told a very different story. Kondrak pushed back almost immediately, telling the Times of Israel his team never claimed to have deciphered the manuscript, calling the result an early signal worth investigating, not final proof. The real problem showed up when they tried turning the theory into an actual sentence. By their own admission in the paper, the first translated line wasn't coherent, and they needed manual spelling corrections plus a pass through Google Translate just to make it read like English at all. Lisa Fagan-Davis, executive director of the Medieval Academy of America, wasn't impressed, pointing out that an algorithm trained entirely on modern languages can't reliably identify the language of a 15th century document, since grammar, spelling, and vocabulary would have looked completely different that far back, and that leaning on Google Translate instead of an actual language expert costs a researcher credibility fast. Kondrak later admitted the reaction from Voynich specialists had been cold from the start. That collapse didn't shut down computational research into the manuscript, it pushed other researchers toward a narrower, more careful question. Does this text behave like language at all, regardless of which language it might be? Back in 2011, computational linguist Kevin Knight and researcher Shravana Reddy had already taken a more cautious approach, building a hidden Markov model, a statistical tool for finding hidden patterns underneath visible data. The same basic technique early speech recognition software used, and running it across the roughly 225 transcribed pages and 8,100 words available at the time. With one narrow goal: automatically sorting pages into the two writing styles cryptologist Prescott Currier had identified by eye back in the 1970s. The model succeeded, and its statistical map lined up closely with the book's illustrated sections. Buried in that same study was a strange detail. The manuscript's letters followed an unusually strict, predictable pattern compared to real languages like English or Latin, a property called low entropy splitting researchers into two camps for the next decade. One reading it as evidence of a genuine but unusual language, the other as a warning sign of something artificial. In June 2013, physicist Marcelo Montemurro led a team, published in the journal PLOS ONE, treating the entire manuscript as a network of connected words using tools from information theory. Real human languages carry a specific fingerprint under this kind of test. Meaningful content words cluster tightly around specific topics, while small connector words spread evenly with little clustering. Running this test across the manuscript, certain words clustered exactly like meaningful content words do in real languages, rather than scattering randomly. The team's conclusion stayed careful. The manuscript's word usage patterns were compatible with genuine meaningful language, not proof of it. That same year, a separate team led by Diego Amancio at the University of São Paulo, also publishing in PLOS ONE, compared the manuscript against a large library of real texts across dozens of confirmed languages, testing three separate statistical measures: whether it follows Zipf's law, how its word network structure compares to real language networks, and how word patterns behave as a reader moves through the text in sequence. Across all three tests, the manuscript consistently landed inside the range produced by real human languages rather than random noise, though the researchers were careful to note their framework couldn't identify which language, nor prove the text carries actual hidden meaning. In 2020, Yale linguists Luke Lindemann and Claire Bowern scaled the comparison up dramatically, building two large digital text collections, one from cleaned Wikipedia articles across dozens of modern languages, one spanning centuries and language families historically and measuring conditional character entropy, tracking how predictable each letter is given the one before it. Running this across their full collection confirmed and sharpened what Reddy and Knight had noticed. Voynich's characters sit unusually predictable, well outside the normal range for ordinary written English, Latin, or most other tested languages. But Lindemann and Bowern didn't treat that as proof of a hoax. They found that certain real historical encoding methods, including systems combining two letters into a single written symbol, can push a genuine language's entropy score down into that same unusually low range. Low entropy alone, in other words, doesn't rule out a real language underneath it, just means that language, if it exists, likely passed through some unusual encoding system first. On the other side of this argument, psychologist Gordon Rugg at Keele University, publishing in the journal Cryptologia, proposed the entire manuscript could have been produced using a genuinely low-tech 15th-century method, a device called a Cardan grill, combined with tables of prearranged word-building syllables, generating an endless stream of invented words without needing any real language, cipher, or hidden meaning at all. Rugg built a working demonstration and argued it reproduced several of the exact statistical fingerprints researchers kept finding, including some of the same low-entropy patterns. A separate, arguably more direct challenge came from Torsten Timm, working with physicist Andreas Schinner, who published a detailed study proposing a specific mechanical, self-referencing process where new words get built directly out of pieces of previous words already on the page, meaning, if real, every statistical signal other researchers detected could be a side effect of mechanical text generation rather than evidence of genuine language. Neither theory has fully won over the wider research community. Defenders of the natural language interpretation argue a purely mechanical process struggles to explain the more complex clustering patterns Montemuro's team documented, particularly how certain words correlate specifically with the illustrations beside them. That unresolved split is exactly the gap that keeps attracting less careful claims of a final solution. In 2019, the University of Bristol issued a press release announcing researcher Gerard Cheshire had identified the text as an extinct language he called Proto-Romance. Multiple specialists, including Lisa Fagan-Davis, publicly called the claim unreliable almost immediately, and Bristol pulled its own press release within a single day. Several self-published papers since have claimed AI-assisted full solutions, one calling the text Old Turkish, another attributing it to a specific named monk, describing astrology-linked medical treatments, none appearing in any peer-reviewed journal. None independently verified by researchers who've studied this manuscript for decades. All following the identical warning signs that sank Cheshire's claim: confident language, dramatic framing, and no outside verification anyone else could reproduce. Meanwhile, in 2024, Lisa Fagan-Davis returned to multispectral images originally captured a decade earlier by a research effort called the Lazarus Project, and identified faint marginal writing in ordinary Roman letters almost certainly left by someone attempting an early decipherment effort long before modern computing existed. It doesn't translate a single word of the actual script. What it confirms is that this manuscript has been treated as a real puzzle worth seriously attempting for a very long time, long before AI, long before statistical modeling, long before the field even had a name for the script itself. So here's where this genuinely stands. Real, peer-reviewed, carefully limited computational research, Reddy and Knight's page mapping, Montemuro's and Amansio's independent statistical analyses, Lindemann and Bowern's large-scale entropy comparison keeps landing on the same cautious conclusion: this text is statistically compatible with real human language, not proven to be one. Equally real, peer-reviewed research from Rugg, Timm, and Schinner demonstrates that simple mechanical table-based methods, buildable by a single person in the 1400s with no linguistic knowledge at all, can reproduce several of those exact same statistical fingerprints. Both bodies of research are legitimate. Both remain actively disputed by their own authors in the same academic journals, and neither has closed the argument. What every single viral solved headline has in common backs his plant names. Kondrak and Hauer's Hebrew claim, Cheshire's proto-romance theory, is that none of them survived contact with the researchers who've spent their careers on this book, and every one of them quietly walked back its own certainty once other experts actually checked the work. If you want a mystery that's genuinely still unsolved rather than pretending to be, this is one of the last real ones. No computer, no algorithm, and no AI model has produced a single confirmed translated sentence from it, and Yale's own research team is still actively working on it right now.